manual transmission, and transaxle. The transmission, or transaxle, is a vital link in the powertrain of any modern vehicle. The purpose of the transmission, or transaxle, is to use gears of various sizes to give the engine a mechanical advantage over the driving wheels. During normal operating conditions, power from the engine is transferred through the engaged clutch to the input shaft of the transmission, or transaxle. Gears in a transmission, or transaxle housing alter the torque and speed of this power input before passing it on to other components in the drivetrain. Without the mechanical advantage the gearing provides, an engine can generate only limited torque at low speeds. Without sufficient torque, moving a vehicle from a standing start would be impossible. In any engine, the crankshaft always rotates in the same direction. If the engine transmitted its power directly to the drive axles, the wheels could be driven only in one direction. Instead, the transmission, or transaxle, provides the gearing needed to reverse direction, so the vehicle can be driven backward. There is also a neutral position that stops engine rotation and power from reaching the drive wheels. Transmission versus transaxle. Vehicles are propelled in one of three ways: by the rear wheels, by the front wheel, or by all four wheels. The type of drive system used determines whether a conventional transmission or a transaxle is used. Vehicles propelled by the rear wheels normally use a transmission. Transmission gearing is located within an aluminium or iron casting called the transmission case assembly. The transmission case assembly is attached to the rear of the engine, which is normally located in the front of the vehicle. A drive shaft links the output shaft of the transmission with the differential and drive axles located in a separate housing at the rear of the vehicle. The differential splits the driveline power and redirects it to the two rear drive axles, which then pass it on to the wheels. For many years, rear-wheel drive systems were the conventional method of propelling a vehicle. Front-wheel drive vehicles are propelled by the front wheels. For this reason, they must use a drive design different from that of a rear-wheel drive vehicle. The transaxle is the special power transfer unit commonly used on front-wheel drive vehicles. A transaxle combines the transmission gearing, differential, and drive axle connections into a single case aluminium housing, located in front of the vehicle. This design offers many advantages. One major advantage is the good traction on slippery roads, due to the weight of the drivetrain components being directly over the driving axles of the vehicle. It is also more compact and light than the transmission of a rear-wheel drive vehicle. Transverse engine and transaxle configurations also allow for lower hood lines, thereby improving the vehicle's aerodynamics. Four-wheel drive vehicles typically use a transmission and transfer case. The transfer case mounts on the side and back of the transmission. A chain or gear drive inside the transfer case receives power from the transmission and transfers it to two separate drive shafts. One drive shaft connects to a differential on the front drive axle. The other drive shaft connects to a differential on the rear drive axle. Most manual transmissions and transaxles are constant mesh, fully synchronized units. Constant mesh means that whether or not the gear is locked to the output shaft, it is in mesh with its counter gear. All gears rotates in the transmission, as long as the clutch is engaged. Fully synchronized means the unit uses a mechanism of brass rings and clutches to bring rotating shafts and gears to the same speed before shifts occur. This promotes smooth shifting. In a vehicle equipped with a 4-speed manual shift transmission or transaxle, all 4 forward gears are synchronized. Reverse gearing may or may not be synchronized, depending on the type of transmission or transaxle. Transmission or transaxle design. The internal components of a transmission, or transaxle, consist of a parallel set of metal shafts, on which meshing gear sets of different ratios are mounted. By moving the shift lever, gear ratios can be selected to generate different amounts of output torque and speed. The gears are mounted or fixed to the shafts in a number of ways. They can be internally splined or keyed to a shaft. Gears can also be manufactured as an integral part of the shaft. Gears that must be able to freewheel around the shaft during certain speed ranges are mounted to the shaft using bushings or bearings. The shafts and gears are contained in a transmission or transaxle case or housing. The components of this housing include the main case body, side or top cover plates, extension housings, and bearing retainers. The metal components are bolted together with gaskets providing a leak-proof seal at all joints. The case is filled with transmission fluid to provide constant lubrication and cooling for the spinning gears and shafts. Transmission features. Although they operating in a similar fashion, the layout, components, and terminology used in transmission and transaxle are not exactly the same. A transmission has three specific shafts: the input shaft, the counter shaft, and the main shaft, or output shaft. The clutch gear is an integral part of the transmission's input shaft, and always rotates with the input shaft. The counter shaft is actually several gears machined out of a single piece of steel. The counter shaft may also be called the counter gear, or cluster gear. The counter gear mounts on roller bearings on the counter shaft. The counter shaft is pinned in place, and does not turn. Thrust washers control the amount of end play of the unit in the transmission case. The main gears on the main shaft, or output shaft, transfer rotation from the counter gears to the output shaft. The main gears are also called speed gears. They are mounted on the output shaft using roller bearings. Speed gears freewheel around the output shaft until they are locked to it by the engagement of their shift synchronizer unit. Power flows from the transmission input shaft to the clutch gear. The clutch gear meshes with the large counter gear of the counter gear cluster. This cluster gear is now rotating. Since the cluster gear is meshed with the speed gears on the main shaft, the speed gears are also turning. There can be no power output until one of the speed gears is locked to the main shaft. This is done by activating a shift fork, which moves its synchronizer to engage the selected speed gear to the main shaft. Power travels along the counter gear until it reaches this selected speed gear. It then passes through this gear back to the main shaft, and out of the transmission to the drive line. Transaxle features. Transaxle use many of the design and operating principles found in transmissions. But because the transaxle also contains the differential gearing and drive axle connections, there are major differences in some areas of operation. Refer to this figure. This transaxle uses fully synchronized, constant mesh helical gears on all forward speeds, and spur gears for reverse. A transaxle has two separate shafts, an input shaft, and an output shaft. The input shaft is the driving shaft. It is normally located above and parallel to the output shaft. The output shaft is the driven shaft. The transaxle's main, or speed gears freewheel around the output shaft unless they are locked to the shaft by their synchronizer assembly. The main speed gears are in constant mesh with the input shaft drive gears. The drive gears turn whenever the input shaft turns. The names used to describe transaxle shafts vary between manufacturers. The service manual of some vehicles refer to the input shaft as the main shaft, and the output as the driven pinion, or drive shaft. Others call the input shaft and its gears the input gear cluster, and refer to the output shaft as the main shaft. A pinion gear is machined onto the end of the transaxle's pinion shaft. This pinion gear is in constant mesh with the differential ring gear located in the lower portion of the transaxle housing. Because the pinion gear is part of the pinion shaft, it must rotate whenever the pinion's shaft is turns. With the pinion rotating, engine torque flows through the ring gear, and differential gearing to the drive shafts and driving wheels. Some transaxles have a third shaft designed to offset the power flow on the output shaft. Power is transferred from the output shaft to the third shaft using helical gears, and by placing the third shaft in parallel with the output and input shafts. Other transaxles with a third shaft use an offset input shaft that receives the engine's power and transmits it to a main shaft, which serves as an input shaft. The third shaft is only added to transaxles when an extremely compact transaxle is required.